All right, welcome everyone. I'm Peter Salemink and I'm the host of today's webinar. As a product owner at Alliander and the chairman of the technical steering committee of the Power Grid Model project, I lead the daily development of the Power Grid Model project. For me personally, climate change is really important and trying to accelerate the energy transition is a major motivation for me to work at a distribution system operator like Alliander. I have been working at Alliander for over 4 years, and I've been involved with the Power Grid Model project from the beginning. I've seen the project and the community grow, and I'm really excited to dive into the past, present, and future of the project together with you and with some guests. Um, with this webinar, we hope to inspire you to start using Power Grid Model yourself or start your own open source project so we can accelerate the energy transition together. For the people that are not so familiar with Power Grid Model yet, I'll give a short introduction. Power Grid Model is a distribution grid calculation library that supports multiple calculation types like power flow, state estimation, short circuit calculations, both for symmetric and asymmetric calculations. Within Alliander, Power Grid Model is a major acceleration in the energy transition, and it's used across many different departments for analysis ranging from grid planning to real-time congestion management. Today I've prepared some questions for each guest, but for each guest there's also the possibility to ask questions in the chat. Due to time constraints, we might not be able to handle all questions live, but we will try to answer all questions that cannot be addressed today afterwards in a special thread on a GitHub discussion board. So if you have a question, please post it in the chat. And if it's for a specific guest, please also mention the name of the person that you're asking the question to. Before we start with our first guest, I would like to set clear expectations of the webinar. So the webinar will be focused more on the business side and less on the technical side. So if you're interested to learn more on the technical details of Power Grid Model or want to learn how to get started, then I'd like to point you towards our GitHub documentation and the Power Grid Model workshop repository. Let's go to our first guest, Werner van Westering. Werner is the founder and lab manager of the AI for Energy Grids lab at Alliander, and he initiated the precursor of Power Grid Model while he worked on his part-time PhD at Alliander. Currently, he's involved in Power Grid Model project as a member of the technical steering committee and as a researcher regarding state estimation. Werner, welcome.
Yeah, thank you.
How did you get started with grid calculations?
Yeah, thanks. We go back a bit further. You said you were involved from the beginning, but I started the precursor to Power Grid Model about 8 years ago at Alliander. Back at the time, we wanted Alliander is a DSO, as you already mentioned. We have about 20 million cables, and we wanted to simulate the impact of the energy transition. And my colleague said, "Help, my Excel files. The limit is 1 million, so we cannot simulate 20 million cables." So that was when we started doing calculations. In the end, they managed to make a simulation. This was a side project, and they managed to do a single simulation, single time step, a single load flow of the entire network. Took 3 months, and well, I thought that was too long. But they were like, "Well, we only do it once a year, so what's the problem?" But that was when we started with developing fast calculations.
Yeah, so doing a calculation that takes 3 months now seems impossible. I think we need a lot faster calculations, but back in the day, I can imagine it was quite hard to convince people that we actually needed faster calculations. So how did you convince, for instance, the engineers that we needed to develop faster power flow library?
Yeah, that wasn't easy because, well, said they thought it was sufficient. But basically, my idea was to develop a capability and then put it in people's hands and see what would happen. It's like, well, what happened with the iPad beforehand? Nobody could tell you what the iPad was for. But once people got it, they had like 1,000 applications. So I was like, well, what if I develop the capability? Back then I was alone. Now it's a team effort. Um, to simulate networks very fast. I think that has many applications. And well, we did a precursor thing in R. It wasn't very high quality. It was fast mathematics though, so that really helped. And we got the simulation time down to 20 seconds. At the beginning, they didn't believe it worked, but eventually, we now use it for many different things.
Yeah. Let's see if there's already a question from the audience. I see there is. There's a question: is it suitable to be used by DSOs as well?
Well, the mathematics aren't much different. You can do it, but it has been specifically developed for DSO, so you might miss a few convenient factors. But in general, the general load flow is the same.
Yeah. Maybe a good addition to that is that we also don't support all the components of a TSO, so the high voltage grid.
I think that is the
because
main issue you're
yeah,
gonna encounter, but the mathematics should be the same. Yeah,
yeah. So excluding those components, it should be possible
exactly. Yeah.
to use. Um, can you maybe give a few examples what benefits Power Grid model brought for us?
Yes. First of all, of course, load flows on a large scale, but that was technically, as I said, already possible. But really new things were, for example, um, doing a load flow is one thing, but determining capacity that is left in your grid on every specific point is a different one. And we leverage the linear properties of the model to to make basically for every point, okay, so many, we've got this many megawatts of space at every point. That was one new calculation we now did, and of course we simulated the entire energy transition with it 40 years ahead, like on a quarterly, on 15-minute time scale, so that's 34,000 data points per year for multiple scenarios. So that was really one of the first big data projects we did at Alliander.
Yeah. And, well, we can already do a lot with Power Grid model, but can you maybe tell us what your next capability would be that you would like to see implemented?
Yeah, those are all in the line of state estimation. I think the main goal at Alliander is getting insight in the day-to-day, the current status of the network, and with current I mean like this second. And state estimation is going to be very important for them. A metaphor I often use is we're trying to regulate the traffic without knowing where the cars are. I want to know where the cars are so we can regulate the traffic better. And I think that is one of the main thing we need to get very good at is the state estimation of the network. And farther in the future, I would also like to include thermal loading. So what is the current temperature of the cable and how can we load the cable according to that temperature? And can we maybe find extra capacity for that? Because that is the main goal of facilitating the energy transition at this moment.
Yeah, thank you. I see there is another question in the chat. Is the model suitable for both balanced and unbalanced networks?
Yes, it is. That's the short answer. You can do balanced and unbalanced calculations with it.
Yeah. Yeah, so within Power Grid model, we have the possibility to go for asymmetric and symmetric calculations,
Exactly.
which is
Yeah.
a different naming for balanced versus unbalanced.
Thank you. Yeah.
So if you have questions, please keep posting them in the chat. And then I have a personal question for you. What are you doing at the AI for Energy Grids lab?
Yeah. So over time, my role evolved a bit from mainly researching to also managing the AI for Energy Grids lab. In the AI for Energy Grids lab, I will keep it brief because it's not the main subject of this meeting, but we do research with academic partners, very applied research, and we try also to develop AI methods for grid simulation. So for example, two examples, one of them is redundancy calculations and -1 calculation. So what happens if one line fails? We developed a graph neural network for that, who even speeds up that also factor 1000 or 2000. Of course, with the disadvantages of machine learning methods, but it's still a very good speed up. The second thing we did also with Power Grid model is using state estimation to estimate the tap changing position of the transformers. The tap changing is the conversion ratio between medium and low voltage, just to keep it short. And our dataset was very bad. We had 80% errors on some locations. And now with combining measurement information and the power grid model, we can simulate and estimate those tap changing positions. And yeah, that's a very valuable thing, because else your voltage measurements, your voltage calculations, they are totally off. So it's very good that we can reconstruct the database this way.
Yeah, so it's really nice to have this collaboration also, well, you within the AI for Energy Grids lab, um, together with the academic world doing research on new topics, and that supports us in the end again as Power Grid model. And maybe we can integrate some of those new algorithms in the future. I don't see any further questions in the chat, so I think it's time to close the session.
All right.
I
Yeah,
would
thank
like
you very much.
to thank you for attending, and then I'm going to introduce the next guest, and that's Tony Xiang. He's a principal scientist at Alliander System Operations, and he's a part-time assistant professor at the Eindhoven University project, Eindhoven University of Technology. And Tony is the founder of the Power Grid Model project itself. Tony, welcome.
Hi, thank you.
What was the motivation for you to start a new project based on the methods of the prototype project of Werner?
Yeah, as we already heard a very beautiful story from Vienna, how we as Alliander have started in-house calculation tools and to progressively build to an open source road. But there is something in between. So we, our colleague Vienna, we tried first to build a prototype to just prove the feasibility of some certain in-house calculations, because we never knew if that will work or not. We always used the commercial solutions before. So we first built a prototype to prove mathematically, physically, we can actually build something in-house and to run the calculation, which can be much faster than the existing solutions at the time. And that turns to be very successful. So we had a prototype which runs very good with a lot of projects inside our Alliander. So we use in many projects to see, hey, some of them for fast calculations on long-term solutions, some of them for short-term solutions, and so forth. But interesting is that the users keep asking more features on that prototype. And as you know, with the software engineering experience, when we build something as a quick and dirty, it became increasingly difficult to add even more features with those very basic prototype. It turns out very difficult to implement. So eventually we had to make decision to say, do we want to do a complete refactoring on the existing prototype code, or let's completely rewrite the code using more professional software engineering principles. Another factor to be taken into account is that the prototype was written in R, which is a very good language for statistics, but not really designed for production running in hundreds of CPUs in the cloud with all the scaling capability. So eventually we decided, okay, let's rewrite the whole software in C++, and that means we also should apply all the basic software engineering principles, like the project has to be modularized with different components. They can be separately unit tested, they can be validation tested, and also like automatic CI/CD pipelines, which you every commit you recheck everything, is that correct or not?
So then a new project was born, Power Grid Model, but it wasn't open source at the beginning. We started it as in-house development. How did we make sure that the project was open source ready when the time came?
Yeah, that's also a very interesting question. So to emphasize, once we had the idea to rewrite the whole project in a very professional way in software engineering and including all the formalities, we already had a discussion with Alliander management to say, hey, we actually had ambition to push this project to open source eventually, and we have got the full support from Alliander and management to say, when the time comes, it should be open source. And we kept this in mind when at the day one when we started to design the new project. And that has to be two aspects, both on the technical aspects and the governance aspects. So let me start with the technical aspect. So to become an open source project, we have to have a strong separation between what is the pure physical calculation, so power flow calculation, how do you model transformer, how do you model a line, how do you do the Newton-Raphson power flow, this kind of stuff, and the business rules inside our company. So how specifically our company's cable looks like, or how our database looks like, and that has to be completely separated. And we have designed in a way that the PE power grid model only contains the formal part, so only the generic algorithms and the generic physical modeling. And another part of the technical is that we only use open source dependencies, so we don't use any other internal project. If we have done that, that would be increasingly difficult to make it open source, because then we had to remove them again, maybe to publish them to open source.
Yeah, I think this is a really good introduction for one of the questions that came in from the audience. And it's, how did you balance internal development with commercially available tools, and how did the vendors respond?
Well, that's a really interesting question. So we have a very strong incentive to make a generic tool which should be usable for many scenarios and many projects. And one of the scope we see in the gap at the market at that time is the missing of a very good software packages, and the solutions in the market were mainly focused on to provide a very nice desktop application with all the interesting draw a line. You draw a line, you run a power flow, you see a lot of visualized results. They are mainly intended for the desktop user to use it. We took a completely different approach. So the power grid model, the main target is always a programmer or a data scientist or professional software engineer who want to incorporate power grid model into a bigger application. And that's also what we try to interact with all the commercial parties to see, hey, we have this nice open source packages, free for use with a very commercial friendly license. Feel free to think about whether this can be a commercial value for you by incorporating this basic calculation engine to a bigger applications which can be profitable in a commercial environment.
Yeah. And then so a lot of people were using either awareness project before, or some other package already. But how do we help existing users to migrate from any of the things that they were using before to Power Grid model?
Well, in general, migration from a tool to another tool is always extremely difficult, especially in the software engineering world, because you have a lot of things to consider. Does it break the existing functionality? Does it deliver the exact same expectation as before? And how does the migration going to prioritize then other interesting activities in the project? So you only have a limited number of programs with a limited number of hours. So what do we do here? So we have a general step and a specific step. And the general step means that we want to bring the awareness of this new project to the organization. So they were already using the legacy prototype project, and then say, let's do more promotions, tutorials, workshops, just to introduce, hey, we have this nice new project. They are meant to be the successor of the old legacy project. We are willing to promote them, give tutorial, and also provide support to actually help the teams to migrate. So that's the first step. But the migration didn't happen automatically. We also have to go to teams one by one to actually talk to the teams to say, what would be an interesting migration plan for this particular application or for this particular project. And usually we'll see in the past, there are two good moments to migrate. The first one is that when they actually needed the new features, which was not there for the old prototype project, and then it's a very strong business case for the prioritization for those applications to say, hey, now we can migrate from the prototype to the new mature packages because the prototype didn't have the features we want. And another moment is that's very specific at our company, is that we had a transition from using a lot of applications based on R language to Python. And when that happens, so when project was in a phase to transition from R to Python and then migrate to Power Query model is very natural.
Yeah.
So that was the idea we had before.
Yeah, and maybe also good to mention to the people that are joining this webinar today is that if you need help to migrate from one tool to Power Grid model, then always feel free to contact us because we're always open to support you in that migration. We have 1 minute left, so maybe a quick answer. What was the scope of the Power Grid model, and how did this clear definition of the scope help with the success of the project?
Yeah, that's also very interesting. We try to scope the Power Grid model to the bare minimum of the physical modeling. So that means we try to model the network, model the components and the network itself, but we try to stay away from the business rules, which are usually very specific for one use case and one application. And in this way, we try to say to ensure the broader applicability of the project. And also in this way, we try to also inspire more collaborations with other projects, both commercial project or open source project, because there's plenty of room to build an application based on the backend of Power Grid model.
Yeah, well, thank you. Maybe we can do one quick question because I see we're a bit ahead of time actually, and there was a new question in the chat. So, Tony, what solutions do you offer for model validation and convergency issues?
Well, for model validation is a very important task for us, also for the whole project, because if we are doing physical calculation here, so if we don't deliver reliable results, nobody is going to use it. And we have like more than 150 validation cases in our project. They are derived from many existing projects, both commercial softwares, other existing open source project, and also a large number of handmade projects. So we really do the calculation by hand, join the circuits, join the formulas, and then calculate it by hand. And then this is the input, these are the expected output. And the project should also deliver the same results. This is built as a part of the automatic testing. So if we or any person in the world contribute a new feature to the Power Grid model, all those 150 plus validation cases will run against the changes of the new Power Grid model. If it doesn't pass, it's not able to merge to main. So
Okay.
yeah.
Well, thank you, Tony. I think we're through our time, so I would like to thank you.
Pleasure.
And then I'm going to introduce our next guest. Unfortunately, Arjan could not make it today, which was on the agenda. But Jonas van der Boogaard is going to join us, and we're really happy to have you here. Jonas van der Boogaard is Digital Strategy Lead and Open Source Office Lead at Alliander. He's responsible for ensuring that open source initiatives align with and contribute to Alliander's digital strategy and objectives. And he plays a leading role in Alliander's open source programming office. And in that role also represents the company on the LF Energy Technical Advisory Commission. You're also part of the Technical Steering Committee of Power Grid Model. Welcome, Jonas.
Thank you for having me, Peter.
Within the energy transition, Alliander was one of the early adopters of open source as a software development approach. What was the motivation for this?
Yeah. As you already mentioned in the intro, Alliander is facing a major challenge, enabling the energy transition for the Netherlands. And we have been putting up our investments in expanding the electricity grid, but we see that's not sufficient. Digitalization also plays a key role. And also in regard to digitalization, we see that only working harder and faster is not enough. And we also have to collaborate. And there is where we see a great opportunity for open source and open innovation. And we see open source and open as a way to collaborate with other organizations. And that can be grid operators, that can be vendors, or even a university or academia, which we can share knowledge, share ideas, and also share the load to develop and the burden of the cost of that development.
Yeah, so you already stressed the importance, but how did Alliander's strategic commitment to open source impact the collaboration with other stakeholders in the energy sector?
Yeah. So if we're looking back, so we have adopted this open source strategy for now a few years. And what we see is that open source is a great platform for shared R&D, especially in the digital space. It allowed us to work on multiple projects, which Power Grid model, which we're talking about today, is a great example of that. It allowed us to work together with stakeholders like grid operators, like vendors, like academia. And that's one part which open source has been very helpful for Alliander. Secondly, open source has also opened new doors. We have been, before our open source strategy, we have already been collaborating with some of these stakeholders. But we see that open source also enabled new parties to join in that collaboration, especially on an international level. Open source is not something which stops at the borders, but goes beyond. And we see that open source created a lot new collaborations also on a European and sometimes even on a global level.
Yeah. Well, let's see if there are any questions for you popping up in the chat. And I see there is. So Jonas, do you have any tips on persuading a company to embrace open source tools?
Yeah. So one of the things I see or I notice in many conversations I have with other organizational stakeholders is that many still see open source as something scary or something which is not ready to use in a production mission critical environment. And the first thing I always explain is the role open source already plays in our current landscape. And for many organizations, they are not aware that open source is a critical enabler for many of their digital innovations. And also that can not only be the innovation they develop internally, but also many of the digital innovations they buy from vendors include open source software. Even the SCADA systems which run our networks includes open source software. So that's one part. It always helps to show that open source already plays a critical role in your organization. And then the next step is how can you further leverage that open source strategy? How can we benefit from the benefits open source have, not only from a user perspective, but also from a co-creation perspective. How can we adopt open source to do shared and collaborative R&D innovation? And then I think the discussion can be very strategical because open source is a really way to bring more external knowledge and resources into your ecosystem.
Yeah. And maybe it's also interesting to look at this from an Alliander perspective. So, well, when we started with open source, what challenges did we encounter at Alliander in the journey to open source, and how have they been addressed?
Yeah. So I think I was already mentioning that open source sometimes, also here at Alliander, was seen as a risk for security. So one of the things we addressed that is explaining that no matter if software is closed source or open source, guarantees security. And also open source software can be very secure. Of course, you have to take the measures in place and take that very seriously, as well as you do also with closed source software. But definitely also has the opportunity to be even more secure because the open source software also provides transparency and has a thriving community around it, which also can help to find security vulnerability more quickly and also help to fix them more quickly. And secondly, it can also be scary to contribute to your first open source project or make your first project open source. So one of the things we did at Alliander is we started an open source program office, which I'm leading. And what we do in this team is help our teams like the Power Grid model, but many others, to go through that journey. So how can you bring your project to open source? What do you have to do from a compliance angle or from a technical angle to get it to open source, and also maintain an open source community and grow an open source community, which can be, if you have never done it before, can be difficult. So it also helps to have a team available to support that effort.
Yeah. Well, then also looking a bit ahead in the future, and also zooming in on the Power Grid model itself. What are your long-term goals and expected outcomes of Alliander's open source strategy for Power Grid model?
Yeah, so the Power Grid model is, as already Tony and Werner mentioned, it's an important digital capability for us as an organization, and we use it in multiple use cases in many applications today. But we also expect that the Power Grid model will play an important role in the future. And adopting an open source strategy will help us to continue to innovate the Power Grid model and take advantage of the community around the Power Grid model to share that knowledge and also share the burden of co-developing it, which provides us as Alliander a low cost of ownership and makes the project more maintainable, not only today, but also in the long run. And finally, I think it's also a lot of fun for our teams working on the Power Grid model, but also the teams out there to be able to work together on this with people which you maybe not work together in everyday life.
Yeah, definitely. If I can say for myself, it's really nice to work in an open source environment and speak to many different companies instead of just the other teams within Alliander. So that's indeed a huge fun factor for me personally. I don't see that there are any questions in the chat, at least not on my screen. So then I would like to thank you very much for attending.
Yeah, thank you.
And then
Peter.
I would like to introduce our next guest, which is Jaap Schouten. He's product owner at Alliander and has been working on implementing Power Grid model within different teams at Alliander. This also resulted in the Power Grid model DS or data science collaboration, a new addition to the Power Grid model software suite, which is actually really new because it was published yesterday. Jaap, welcome.
Yes, thanks for having me.
Well, let's start with Power Grid model DS. So with Power Grid model DS, you are adding a new package to the Power Grid model suite. How does it enhance the Power Grid model capabilities?
Yes, yeah, well, like you said, this webinar has great timing since we have put in the effort last month to add this new piece of software, which we have been using internally for a while now, also to the open source part of the Power Grid model. And it's, like the title says, it's a data science toolkit. So it came about from a lot of different teams within Alliander implementing the Power Grid model. And they had similar needs and use cases for interacting with it in a data science setting.
Could you maybe discuss some of those potential use cases of Power Grid model DS?
Yeah, so I think what we have with the Power Grid model is, of course, a really fast calculation core. And to be able to use that within our applications, I think there's a couple of things that we managed to make easier with the data science toolkit. And that's, first of all, that we have some tools for preparing the network, filtering data from our internal data before putting it into the Power Grid model. And that's a lot easier with a really clean Python interface we built around. And on the other hand, after doing this calculation, it makes it easier to analyze the results in the context of the question you are asking. And also, which is really nice, simulate changes to the network. There's a lot of teams at Alliander, of course, not only doing calculations, but also looking for solutions. Long-term, short-term solutions, and that is made easier through using the Power Grid model data science interface.
And for which use cases did you use it yourself?
So one of the teams I was involved in is trying to make optimal investment decisions, and for that we're changing the network iteratively, so in a genetic algorithm. And constantly trying to rerun the Power Grid model calculation and see if the investments make sense. So that's something that's now very easily implemented using the toolkit. Yeah.
Yeah. And how does this package align with the Alliander open source strategy?
Yeah, so I think, like Jonas said already, that we are really invested in sharing what we do with the outside world to enhance innovation, to create better quality software. And that's also what we did here, and also in a little bit in the same strategy like the Power Grid model itself. We first grow the project a little bit more internally, mature it with in the back of our mind, okay, this is something we want to be able to share with others. So make already the decisions from the starting point, which are in line with that strategy.
Let's see if there are some questions in the chat. And I see there is. Does Power Grid model include some visualization methods of the input and the output? For example, is there a visualization of the input net topology like lines, nodes, sources, etc.?
Yeah, so I think that's one of the things we're actively working on. So actually, we have still some development we're doing. So for the package we have open sourced last week, the visualization is not yet part of it, but we're working on a package where we try to also do that. And it's a little bit more of a challenge because every visualization has a little bit their own needs. But we hope to be able to add that as well. For now, we only open source the part for interacting and modifying the network.
Yeah, and well, as you mentioned before, it has been used for quite a while internally within Alliander, but we just open sourced it.
Yeah.
Can you tell us maybe something about the internal collaboration that led to the origin of this package?
Yeah, sure. So I think with all ideas, they start with for example one team where some good piece of software pops up, and I think the success for this shared collaboration inside Alliander came from mainly two things. On the one hand, we have a traineeship option, so that means that people do start at Alliander and see different teams, and through that sharing of knowledge between teams, people in different teams knew from the first team about they are developing something that we would like to use. So how can we then take the step to make that something we can share internally as an inner source package? And I think that collaboration is enhanced because we have a very strong data science community. We're organized in so-called chapters, which also gives us space and time to invest in setting up something that's not just used for one team.
Yeah, and I think there is a new question in the chat. Does Power Grid model DS use SIM model for MV/LV grids?
So what the internal structure for the DS package does is it's very similar to the or actually based on the Power Grid model data structures. So they match, and for the so it also can interact with the SIM model, but for conversions to SIM itself, there's different tools we're working on, and also working on with you in the IO packages, I think.
Yeah, and maybe nice to mention because SIM is mentioned now. It's the common information model, but it's not so strict. So within Alliander, we actually use it quite a lot, but we made it an Alliander data model because it didn't have everything that we needed at this moment. So that's also why there's no conversion, for instance, for SIM open source yet. Well, because it's just Alliander. So we are working towards that, and we hope we can do that in the future. I see there's another question in the chat. How long have you been running these tools for grid planning?
So the projects which we are working on, I think the first one maybe started 4 years ago, something, a little bit of a guess, but I think for some time now. So these projects are running for quite some time and still being developed further.
And then if we look at the general projects that we use within Alliander, to what extent do we intend to make internal projects related to Power Grid Model DS, for instance, available through the open source community?
Yeah, so I think that's one of the nice steps by adding this this DS package already to the open source suite for the Power Grid model, is that it enables us to collaborate even further. So when there are projects we now have internally or see externally on which we see the opportunity to collaborate, that's something we're very committed to. That's why we're doing this. That's why we have an open source strategy. Yeah, that's something we're pushing towards always.
Yeah. And then maybe one last question. What are your expectations or aspirations for contributions from external collaborators to enhance Power Grid's model functionality?
Yeah, first of all, like I said in the previous question, so there's hope for collaborations extending on the Power Grid Model DS package. But of course, also to enhance the capability of the package itself, improve it by other people using it, getting feedback, and I think that would be a great first step.
All right, then I see there are no questions anymore, so then I would like to thank you, Jaap.
Thanks.
And then I'm going to introduce our next guest, which is Nikolaos Paterakis. He's an assistant professor at Eindhoven University of Technology. His research interests include power system modeling and optimization, and he's also the university's contact person for LF Energy. Welcome.
Thank you for having me.
The TU Eindhoven, and then in particular the Electrical Energy Systems group that you're working for, has just joined LF Energy as an associate member. What ambitions of the TUE, or what are the ambitions of the TUE in the LF Energy community?
Indeed, TU Eindhoven is a new member of the Linux Foundation Energy. Specifically, we joined last August. Obviously, LF Energy hosts an array of exciting projects, and as a research group, we wanted to be more directly connected to that community, and that's our main motivation for joining. And as regards our ambitions in contributing to LF Energy projects, well, at the moment we are using several projects at an increasing rate, both in our teaching and research, for example, Power Grid model. And as a result, we get more experience regarding the limitations. Sometimes we find bugs and we can report that. And maybe in the future, we can also be more active in contributing to core features of Power Grid model and perhaps other projects.
Yeah, and I just heard you're saying that Power Grid model is already actively used within the group. Can you elaborate maybe on the benefit that Power Grid model has brought for your researchers?
Yeah, so Power Grid model is used for a variety of projects. They range from real-time distribution system optimization to projects and studies related to the impact of local markets on the grid. And also it's being used as a tool in co-simulation environments that my colleagues are developing. PGM is an open source project, and as a result, there is the first benefit is, of course, that you need transparency in research. So if you are using an open source project, then directly you can look under the hood, and everybody has access to the same assumptions that the developers are making, and gives a bit of more credibility. Also, when it comes to Power Grid model, we use it for fundamental calculations such as running power flows. And obviously there are many tools, but there are several reasons why we think Power Grid model is really valuable to us. First of all, we have great performance, which reduces simulation times, and that's particularly important if you're running a large grid or you're simulating a lot of different power flow cases. The second benefit is that it's very well documented, and that's really important because you have a guide about every type of study that you can do currently with Power Grid model. So if you have a researcher with basic knowledge of Python, they can you can set them up really, really quick. And finally, and last but not least, Power Grid model has a very active maintainers group. So if you have any technical difficulties, you are certain that there is somebody that can help you very, very quickly. So that's quite important for us as well.
Yeah. Well, it's great to hear that that Power Grid model is of such high benefit to the university. But during the integration of Power Grid model, you also encountered some missing features that you needed. The group is now actually contributing to Power Grid model by adding this feature. How was the experience of contributing to Power Grid model?
Yeah, so some of my colleagues, they were developing eco simulation environment, and they needed to do some asymmetric calculations, asymmetric power flow calculations, and then they noticed that although Power Grid model supported already asymmetrical power flow, there wasn't an asymmetrical branch component, so they decided to implement that. I didn't work on the component myself, so I'm just transferring what my colleagues are telling me. So they were actually, about the experience, they were actually very, very happy with the fact that the maintainers were very welcoming of external collaborators. So they were very happy to guide my colleagues through the contribution process, also explaining the architecture, the code base. And I believe right now that component is about to be finished, so there is the testing phase to be made. And all along, I would say that the maintainers were very constructive in reviewing the work of my colleagues and also making suggestions. And this is one of, I think this is a very good example of an open source project where, external collaborators are actually welcome, and it's also made sure that there are procedures that will help all contributors be efficient in developing their modules and features.
Yeah, we're actually really happy with the contributions that you're doing. So if anyone else wants to contribute, please go ahead. Looking ahead at the near future, what kind of new features would academic research like to see implemented in Power Grid model?
Yeah, I could give you a wish list based on the discussions with my colleagues. One of the things that come up is the limited support for visualizing your output. And of course, Tony explained earlier that the target audience is really the programmer and not the desktop user. But sometimes having visualization helps. So the new package that Yap introduced a while ago, that will be very helpful. And I think it moves in a direction where you can interpret the results quite fast. And when it comes to core functionality, I would say that it would be interesting to see some optimization capabilities being integrated in PGM. For example, it would be very helpful for a variety of studies if you had optimal power flow sort of calculations integrated potentially in conjunction with some high performance open source solvers. I think that's core functionality that would be quite useful.
Yeah. And did you see those requests as well, maybe on the GitHub issues already, or?
I haven't noticed. Regarding visualization, yeah, there is a lot of discussion, of course. But regarding core functionality like integrating optimization capabilities, I haven't seen anything. It doesn't mean that it's not there.
Yeah. Well, if it's a high request from the university, then I would invite you to write an issue about it. And also for the people online, if you have any feature requests for us, then feel free to add a new issue to the GitHub board. But also, if you want to implement it yourself, that would be even better, of course, for us. And we would be really happy to support you along the way, as we did with the university as well. I think we have time for one more question. The TU Eindhoven hosted the last Power Grid model meetup last year, which was a big success. What was the added value for the TUE of hosting such an event?
Indeed, TU Eindhoven hosted the 5th Power Grid Model event back in June 2024. It was an event that was quite successful. I think there were more than 100 attendees overall, both virtually and in person. The benefit for TUE is that a lot of our colleagues had the opportunity to present their work and how they made use of the PGM library. But in addition to that, also a lot of the researchers had the opportunity to meet the main developers of PGM, and that was really a good opportunity for them to see that there is an active group where they are welcome to contribute.
Yeah. Well, that's great to hear, and well, I think we're through with time. So then I would like to thank you very much, and then I want to introduce the next people, I should say, because for the final part of the webinar, I shared a table with two people you've already seen today, Jonas van der Boogaard and Tony Xiang. As members of the Technical Steering Committee, we will talk about the future of the Power Grid model. Welcome. To start with Tony, I have a question for you. In what ways will the future Power Grid model further enhance reliability and efficiency of the energy distribution?
Well, thank you for your question. So we see in the trend of application of AI-driven models in the world, not just in power system world, but in many industries and sectors in the world, and the increasing usage of AI-driven model actually needs a more fundamental high performance calculation engine for that. Why? When you want to run some AI-driven models, like for a load forecasting or for many AI-driven optimizations, you need a large number of training data set and a validation test set to actually train the AI model, whether it's if it is a neural network or other traditional AI models. And to be able to do that, you need a very high performance calculation backend to actually generate those data sets. And that's what we see applied a lot. Power Grid model get applied a lot in those kind of researches and industry applications. So we have a AI-driven project running live at this moment, using PGM as a backend to generate a data set for both the industrial applications and the academia world. And another interesting part of the progress of Power Grid model is actually the application of the AI model itself into the calculation core. And that's especially interesting when we see statistical driven model calculation like state estimation. Of course, we have the conventional statistical weighted least square model for state estimation, but we also see many new researches in the literature publishing with AI driven models applying graphical neural networks or physics informed neural networks to actually boost the state estimation accuracy or reliability with high level of uncertainty. And we see a very high chance that this kind of model eventually get implemented in Power Grid model.
Yeah, and I think that's also a really nice connection between your role within Alliander and at the university to connect both the academic world and what we need as a company.
Yeah, indeed.
Then I have a question for you, Jonas. What are the long-term goals and expected outcomes of the Power Grid model project?
Yeah. So one thing Tony also was just mentioning is that the work is not done for the Power Grid model. And we have a lot of things to improve and to include, and there's a lot of potential in the project, which we also intend to keep in investing from an Alliander perspective. But we also believe that the open source approach will help us there. It will help us to lower the cost of ownership of the project, but also leverage the great experts and broader community out there to co-innovate together, to leverage their ideas, their resources. I think that example just was given from TU Eindhoven is a great example. We see that bringing together research and PhD students to bring their ideas, innovative ideas to the project, and allowing us to bring those results into production more quickly is really great. and I expect that to continue in the future, and hopefully with a bigger community that will be growing, become more diverse and more internationalized, and looking forward to that journey.
Yeah, it sounds good. Um, then I'm moving over to you, Tony.
Mhm.
What opportunities exist for distribution system operators, commercial parties, and maybe researchers to benefit from the advantages of the Power Grid Model project?
Yeah. Well, I would like to come back to this question, to the question I already have answered before. So Power Grid model, the scope is really designed in a way as a basic components for as the calculation engine. And I already explained that in the functionality part, we have chosen to really do the bare minimum physical calculation now with many also other data science toolkits to expand that functionality a bit, but then still we focus on the physical calculation. So uh, if we see the applications of both DSOs and the commercial parties or consultancy companies, and then we see the opportunity to expand the feature of Power Query model with the actually the other bigger applications and with all the stuff around the calculation engine to deploy an application and so forth. This also applies from IT perspective. Power Query model is a software package, so that means it doesn't have any application, it doesn't have any deployment, database connection, also no graphical user interface. We might have some visualization for Power Grid Model DS. There is also a huge opportunity for commercial parties or DSOs to build up the customized application for a certain use case.
All right, thank you. Then we head over to Jonas again, because I don't see any questions coming in from the chat, so I have some questions prepared, of course. How do the concepts of open source and open governance contribute to the success and further growth of the Power Grid Model project?
Yeah, so we mentioned already a lot about how open source helps in the outcomes of the Power Grid Model project and the roadmap we have envisioned on us. But let's talk about open governance. Yeah? So one of the aspects which is unique in open source projects, that there is also a very transparent way how decisions are made. And I think that's also crucial in open source project. That, for example, the Power Grid Model TC is a meeting where important decisions are made, but it's an open meeting where everyone can join if interested. And secondly, that is also very transparent what the roadmap will be and the issues to be worked on. So I think, Peter, you mentioned many times, refer to the GitHub issue board, which provide a full overview of all the open issues which are brought in by the community, by colleagues of Alliander, but also from TU Eindhoven, Nexus, and broader, to create an overview of wishes for new features or potential or bugs that are in the software. And it also shows progress on those items. Are those worked on those items or not? And I think that's a crucial part of what makes open source project work. That's a very transparent approach. And it doesn't mean that if you put up there an issue, you can expect that it will be picked up right away. I think that's also a good thing about open source is if there's others which are also interested in the same future, you can go in a discussion and see, hey, this is both valuable. Can you pick this up, or can we pick it up together? So hey, you have the opportunity that maybe someone else in the community will pick that feature request up for you. But secondly, if it's very important for you and you have a lot of urgency, you also have the opportunity to take matters in own hands and start implementing it yourself. You don't have to wait for with traditional software. You have to wait on a vendor. The open source provides you also the opportunity to get started with it yourself.
So what type of actions can the audience take to support and engage within the Power Grid Model project?
And I always say that sometimes it can be can feel like a big step to contribute to an open source project. And one thing I always mention, there are many ways to contribute to an open source project. So contributing to the core of Power Grid Model can be quite difficult. Maybe not everyone has the skills to do so, but that's not the only way how you can contribute to a project. It's already a great contribution to the project if you share the project with your colleagues, or create more awareness around this project at an event, or just a lunch or a coffee with other stakeholders in the sector, which is already very helpful and a contribution to the project. And secondly, contributing to documentation, improving the documentation, maybe fixing a spellings mistake, or improving our validation tests, or is also ways to contribute which are maybe more easy or easier to start with.
Well, thank you. Before we go to the actual ending of this session, I would like to ask if you maybe have any questions for me.
Well, because you have just been appointed as the new chair of this project, I'm curious, what are your ambitions to lead this project forward?
Well, for me, my dream is that Power Grid Model becomes a major accelerator of the energy transition, not just here at Alliander, but everywhere around the world. And to support that, we, on one end, try to support Power Grid Model with as many features as possible that are needed by the community. But on the other hand, we also want to help the community to transition from whatever tool you're using at this moment to Power Grid Model to get you started. So we have a lot of good documentation and also workshops already present for that. But if that's not sufficient or you need something else from us, and then I'm looking directly at the camera, please contact us because we're happy to help. And if you are missing features that are really needed to move from one tool to Power Grid Model, then also contact us or make an issue on GitHub because we're really happy to support you. And then I think we come to the ending of the session. So I would like to thank you both.
My pleasure.
And then I would like to thank all of the speakers and also the audience for their active participation today. I think we had some interesting questions from the audience. If there are some unanswered questions in the chat, they will be answered in a GitHub discussions board. If you want to learn more about Power Grid Model, please visit our GitHub documentation. If you're interested in collaboration, you can contact us either through GitHub or send an email. And if you want to stay updated about the project, please subscribe to the mailing list. These the things that I just mentioned will pop up in the screen after I'm done talking, so please hang on. And last but not least, I'd like to point you to our yearly meetup. It's going to happen in spring this year. There's no exact date, but you can subscribe through the LF Energy website. During the meetup, we look back at the previous year and we gather input from you, our stakeholders and the community for the roadmap of the coming year. The meetup is also a great opportunity to meet other people from the community as well as the Power Grid Model maintainers. And well, with that, I'd like to close the webinar of today. Thank you all for attending, and I hope to see you again.